Welcome to JD's Prep. All right, so we're given a diagram here representing a portion of the scheme for igneous rock identification, which I've also pulled up over here from your reference tables. We're going to be using both. Our first question is asking us about rock 1. This line here, AB, is representing the percentages of minerals in that rock, and we are told that it is a glassy vesicular igneous rock, and then we're asked to identify it. So we'll head over to our scheme for igneous rock identification. We know that we're talking about something in this area, so we're looking at some of these rocks. If you look over to the right, we can see vesicular there and glassy there, and the only rock that fits all of those things is pumice. Our next question asks us, compared to the color and density of igneous rock 1, describe how the relative color and density of igneous rock 2 are different. We know that rock 1 is going to be around here, rock 2 and around here somewhere. Okay, and I want to draw your attention to these characteristic scales right here, so we can see that over to the right is darker, and it's also higher in density. So our correct answer would be that the relative color and density of igneous rock 2 would be darker and higher density than rock 1. Next question asks us to explain why andesite and diorite can both have the same percentage of mineral composition by volume and yet be two different igneous rocks. So andesite and diorite are highlighted on your scheme right there. You can see that they have those same percentages. However, there are differences between them, right? One is extrusive, one is intrusive, which means they're formed in different environments. And they also have different textures. So because of their different ways that they are formed, they might have cooled at different rates. So they have different grain sizes and they just have different characteristics. And our last question is asking us to look at rock 1 and rock 2, and using this table down here, look at this mineral composition to determine whether each of those minerals is found in both rock, neither rock, or just one of those rocks. We're going to need this from our reference tables, the properties of common minerals, to figure out what mineral we're talking about based on the composition, because you're not expected to have memorized those. So we're looking at these chemical formulas and identifying those minerals using the table. So we have here. All right, so starting here with this mineral that is Plagioclase Feldspar. It is present in both rock 1 and rock 2. Next we have this mineral here, which is potassium feldspar, which is only present in rock 1, sorry. And lastly, this mineral here is olivine, which is present in actually neither of them. All right, thank you for using JD's Prep.